Hi guys, in this video we'll be proving the formula that states that the change in displacement is equals to the initial velocity multiplied by the time plus half the acceleration multiplied by the time squared. So for you to be able to prove this equation, you first need to assume two things. First, assume that the acceleration is constant. Secondly, assume that the object starts at an x position of 0 and travels for time t. It is important for you to know that the average velocity is equals to the change in displacement divided by the time. If we multiply both sides of this equation by the time, we are going to get that the change in displacement is equals to the average velocity multiplied by the time. Let's make this our equation 1. Secondly, the acceleration is equals to the change in velocity multiplied by the time. Now you know that the change in velocity is the same as saying that the final velocity minus the initial velocity. This means that the acceleration is equals to the final velocity minus the initial velocity divided by the time. If we multiply both sides of this equation by t, we are going to get that the acceleration multiplied by the time is equals to the final velocity minus the initial velocity. If we take the initial velocity to the other side, we are going to get that the final velocity is equals to the initial velocity plus the acceleration multiplied by the time. Let's make this our equation 2. Equation 2. So remember we said that the acceleration is constant. So because the acceleration is constant, it means that the velocity is actually increasing at a constant rate. This means that the average velocity is the midpoint between the final and the initial velocity, meaning that the average velocity v bar is equals to 1 over 2 final velocity plus the initial velocity. Let's make this our equation 3. Equation 3. So let's take equation 3 and substitute it into equation 1. So remember, equation 1 says that the change in displacement is equals to the average velocity multiplied by the time. This was our equation 1. And equation 3 says that the average velocity equals to 1 over 2 of the initial velocity plus of the final velocity plus the initial velocity. This was our equation 3. So now we substitute equation 3 into equation 1. Equation 1. This means that the change in displacement is equals to the average velocity, but instead of writing the average velocity, since we know that the average velocity is the same as this, we are going to put this in the place of average velocity. This means that the change in displacement is equals to 1 over 2 v plus u multiplied by the time. Let's make this our equation 4. Equation 4. We're not done yet. So what else do we know? From equation 2, we know that the final velocity is equals to the initial velocity plus at. This was our equation 2. So if we take equation 2 and substitute it into equation 4, let's see what happens. Sub equation 2 into equation 4. So The change in displacement, this is from equation 4, is equals to 1 over 2 v, but instead of writing v, because we know that v is actually equals to this, we are going to substitute v with this. So this means that this is actually equals to u plus at plus the other u that you see there multiplied by the time. So the change in displacement equals to 1 over 2. Inside we are going to have 2u plus at multiplied by the t that's outside, like this. So now we can multiply in. From there you can see that the change in displacement is actually equals to 2 over 2 u plus 1 over 2 at, like this. And finally we can multiply that t in, because this and that cancels out. We are going to have that the change in displacement is actually equals to ut plus 1 over 2 at squared. And this is the equation. Thanks for watching.